Welcome to this introduction to cross-platform development with Xamarin. My name is Philip Ekberg and I will be your tutor in this tutorial. The objectives of this tutorial is to give you an understanding of how you can target different platforms when developing applications using Xamarin. The whole idea of using Xamarin is that we can reach all the major platforms with one code base. So in this tutorial, we will look at the different ways to share code among different platforms, and we'll talk about some of the benefits of the different strategies. So the objective of this tutorial is to get you to understand cross-platform development. And we're going to do this by looking at how we can create shared libraries, and how we can create portable class libraries, and we'll talk about how the shared libraries differentiate from the portable class libraries. And then we'll also talk about what Xamarin Components are and where you can find these reusable components. Looking back over the years, the way that we've done cross-platform development has changed rapidly over the, let's say, past 5 years. We've seen different approaches in terms of going all native, which means that we're writing one application for iOS, one for Android, and one possibly for Windows Phone. Then we've seen applications written in responsive design, using just HTML, CSS, and JavaScript. And then we've seen this transition into an application that is partially HTML, CSS, and JavaScript, but has a native wrapper. This is called hybrid applications. And now with Xamarin at the table, we have yet another approach for cross-platform development. As you probably already know, Xamarin enables us to run our applications on the native platforms. That means that we're getting a native experience and a native performance. This means that the users on the iOS devices get an iOS application, the users on Android will get an Android applications, and our Windows Phone users will get a Windows Phone experience. So without letting down on any of these really important aspects, which is native performance and a native user interface, we want to reach all the major platforms. So we want to reach all the iOS, Android, Windows Phone, and the Mac devices. In summarizing all these together, we get about 2.6+ billion devices, and that's quite a lot of devices out there. So with Xamarin, and a good cross-platform strategy for code sharing, we can reach all these platforms. Now there are some different strategies out there when it comes to cross-platform development. However, when we're doing development in Xamarin, there are two different aspects that are important to us. However, as you see here, most of the code is shared in the backend. With the release of something called Xamarin Forms, which is not covered in this tutorial, you can also share some of the UI. And in this tutorial, we will focus on code sharing in the backend and how we can optimize the code sharing to have as much code as possible shared among our different platforms. What differentiates these two different cross-platform strategies with one another is that the one that is introducing a shared UI code library as well is taking advantage of something called a shared library. Now the shared library doesn't only have to be used for sharing the UI, it can be used to share the code logic as well, which is why we're going to take a look at both the shared libraries and the portable class libraries. So let's now take a look at how we can create a shared library, what the structure of a shared library is, and how we interact with that from our different platform-specific projects. Now let's take a look at the shared libraries and try to understand how they work and where they're most suitable. The first thing that I've done here is that I've set up the Xamarin iOS build host so that I can go into Visual Studio and still debug, deploy, and run my iOS application. The reason that I want to be in Visual Studio and not in Xamarin Studio is that in a true world of cross-platform, I also want to target the Windows Phone devices. So let's now head over to Visual Studio and have a look at an application that makes use of the shared library. I've created a new project here called Redify.Xamarin. Now you can do this by going up to File, New Project. And what I've done is that I've created a Xamarin Forms shared project. The reason that I'm doing this is because the shared projects were initially created for us to do shared UI code. They were introduced with an update that lets you do universal applications for Windows Store and Windows Phone applications. However, Xamarin is also making use of this technology to letting us share code when it comes to the UI for Xamarin Forms. Now this video isn't about Xamarin Forms, but I'll show you how the shared project works and why it's important to understand how they operate. Since they're not only for the UI code, you can also put your logic in these shared projects. So let's take a look at what this looks like. Now the project structure here is quite simple. We have something on the top here called redify.xamarin. That's our shared library. Notice that it has a quite different icon from what we're used to. Now that'll make more sense now that I expand this here and show you what's inside this project. As you see here, there's no references, there's no assembly information or anything like that. That's because this is not a true project per se. What's going on behind the scenes here is that when the Xamarin Android, Xamarin iOS, and Xamarin Windows Phone project references this project, it'll include the files during compile time and make them a part of that platform-specific project. So, heading down to the iOS project here, we'll see in the references that we have a reference to the redify.xamarin project. This simply indicates to the compiler to take all the files and make that a part of the compilation of the xamarin.ios project. Now, if we just run this here without having a look at the files, you'll see that this starts an application on our iOS simulator. I just need to change this here to the iPhone simulator, and let's run this here. It'll fire off the iOS simulator on our Mac here, and once this is started up, we'll see the application saying something like Hello Forms. So remember, it's not really important what Xamarin Forms is, we're just using this to demonstrate how the shared project works. Let's head back to the code here and make a change. All these different platform-specific projects, they're referencing this app file here. The app file is simply setting up everything to render it nicely on screen, and we can see the Hello World text here that we just saw rendered on screen here. So I want to change this. I want to make use of some specific repository that I've created inside my redify.xamarin project. This news repository that I have in here, let's just expect that something is going on in here. It fetches some news from somewhere, it doesn't really matter, but we want to render this on our main screen here. So I'm going to go over to the app file again. I'm going to instantiate the news repository. Of course, in an ideal world, we'd have this injected into our class here. So let's go ahead and create an instance of this. And we know that we have the getNews method on this repository, so we can call repo.getNews. Now, running this here will get us a different result from what we saw before. So remember it said Hello Forms before. In this case, it'll render something different. It'll say Hello iOS. So let's head over here and take a look at what's going on when we run this on a different device. Let's tell it to run this on Windows Phone. And run the project. Just need to change this to any CPU. And what I'll do first is that I'll start an application called Project My Screen. This will let you see whatever I have on my device here, so now I'll head over to Visual Studio and tell this to debug this application on my device. The application is now being compiled and deployed to my device, and hopefully we'll see a quite different result when this is launched. And exactly that is happening. And exactly that is happening now. So now we're seeing Hello Windows Phone. However, we know that the news repository is used within the app file to retrieve the news, and it's used in a shared project that is being a part of the compilation process when we compile these platform-specific projects. So how does this work? Let's go ahead and have a look inside the news repository file here. So if we expand the region here called compiler directives, it'll all make more sense. So as you see here, we have if this is a Windows Phone device, say Hello Windows Phone. If it's iOS, it'll say Hello iOS, and if it's Android, it'll say Hello Android. However, I want to fetch some content from a website instead. So I pulled down all the data from redify.net by simply removing these compiler directives here. Get rid of the region as well. I know a lot of people don't really like regions, so let's get rid of that. What's interesting here is that the project doesn't have any references at all to any NuGet packages or any other projects. How come that we can use the HTTP client when it's not really a part of our shared projects? The fact is that I installed this through NuGet into my Android, iOS, and Windows Phone project. And as this file here is going to be a part of the compilation for the platform-specific project, it'll know about the HTTP client when it's compiled. So now if we switch over to iOS again, we'll see that this will fetch the redify.net website. So let's go ahead and say that this is going to be an iPhone simulator. Let's start the debugger and see what happens. So let's head over to OS X again. And of course, it's downloading all this data from the web, so it'll take some more time to render this and to execute the application. Now, this isn't really looking that pretty, but it proves the point that this uses the HTTP client that is referenced within the platform-specific projects itself. Just to prove that, let's go ahead and take a look at the references. We'll see here that we have a reference to system.net.http, and this makes it possible to use the HTTP client within the shared projects. So we can combine the shared projects and NuGet packages and make a really powerful application where code is easily shared among the different platforms. Further on, we'll take a look at a better approach for sharing business logic and sharing code like this here by introducing portable class libraries. So having a look at the shared library, let's now take a look at how we can create a portable class library and how the portable class libraries differentiate from the shared libraries. Let's now go ahead and see how we can change this application that we created before to introduce a portable class library. What I'll do is that instead of using the news repository in the shared project library, I'll be injecting an implementation of an interface that I have defined in a portable class library. So let's first go ahead and create our portable class library. We can do that by right-clicking on our solution and do Add Project. And as you see here, we can either do the class library for Xamarin Forms, but I'll also show you that we have a few other project templates installed for portable class libraries. I'll be selecting the first one, which is a portable class library for C#. Let's call this redify.xamarin.core. When creating a portable class library, we can select the different platforms that we want to target. In this case, we want to target the .NET Framework 4.5. We also want to target Windows 8, Windows Phone Silverlight 8, and Xamarin Android and Xamarin iOS. And we can make different selections in here to target different platforms. However, each combination is a specific project. So what happens is if I deselect Xamarin iOS here, it's going to tell us that there's not really a portable class library that is defined for .NET 4.5, Windows 8, Windows Phone 8, and just Android. It'll also make it possible for us to reference this within Xamarin iOS. So let's go ahead and create this portable class library. And now I want to create an interface in here, which I'm going to create implementations for in my different platform-specific projects. So let's call this interface iDeviceInformation. This interface iDeviceInformation will simply have one method which returns the information about the device, or some arbitrary text. So let's just define a method in here which returns a string, and let's call it getInformation. Now that's all there is to our portable class library. Let's also go ahead and rename the file here. So now our portable class library has this iDeviceInformation in it. So let's go ahead and create the implementation inside the Xamarin iOS project. What I'll first have to do here is that I'll need to reference the redify.xamarin.core portable class library. So now let's go ahead and create an implementation in our iOS project for the iDeviceInformation interface. So let's just call this device information, and this here is going to be a public class which simply implements iDeviceInformation. And in here I'm just going to return hello from iOS. Now let's try and compile these two here and see what happens. First let's compile the portable class library and then compile our iOS project. So now we want to go over to our app file, and instead of using this news repository, I'm going to say that the getMainPage method takes this iDeviceInformation. However, before we can do that, remember that I said that this is linked in during compile time. So we'll also have to add a reference in the other projects. So we'll have to go over to our Windows Phone project and add a reference to this here. We'll also have to do the same in the Android project. And then we should be able to resolve this here. Now we'll be able to use the iDeviceInformation inside here. So instead of saying repo.getNews, we want to do deviceInformation.getInformation. And simply use that as the text that we display on our main screen. So let's go ahead and run the iOS application. What you'll see here is that we haven't injected the implementation to the getMainPage method yet. So we need to do that first. We could simply do new deviceInformation, and this implementation is the one that we have inside our iOS project. So now that we try to run this again, we'll see that this will compile it, it will deploy to the iOS simulator, and we'll see that it says hello from iOS. And just as we expected, that's exactly what we see on our main screen now. So now what we've done here is that we've created a portable class library that defines something that will be implemented on each specific device. So we could easily go ahead and do the same change on our Windows Phone project and create the implementation for this. Let's just copy the file over that we call device information and make the same change inside our Windows Phone project. But instead of returning hello from iOS, let's do hello from Windows Phone. So when we compile this here, you'll see that it complains about not getting the implementation path to get main page. So let's just do that. And setting the Windows Phone project as the startup project, let's run this on our device. Let's head over to Project My Screen, and now we'll see here that it says hello from Windows Phone. So now we've seen that we can combine our shared projects with the portable class libraries. The portable class libraries allows us to create interfaces and classes that are shared among our different platforms. And a good way to abstract implementations is to put all the interfaces that you want to share across the different platforms inside a portable class library and then provide the implementation in the platform-specific projects. Another good example of what we could do here to make the application even better is to take the news repository, and we can transfer this news repository into the portable class library and then reference the NuGet packages within the portable class library instead of having them referenced in each platform-specific project. Since there's no platform-specific code inside the news repository, that's a really good opportunity to do something like that. I now hope that you've seen the differences between using the portable class libraries and using the shared projects, and that you've seen that you can combine these to create a really high level of code sharing among your different platforms. In the essence of reusable code, there's something called the Xamarin Components Store. The Xamarin Components Store is available for us online, it's available for us inside Xamarin Studio, and it's available for us in Visual Studio. It gives us a lot of predefined components that people have created for us. A while back, I wanted to create an application to track my diving. And looking at the dive logbooks, each dive has a requirement to be signed by either your dive buddy or your dive master. Now, I don't want to go ahead and create my own signature component inside iOS, Android, and Windows Phone, so I had a look in the Xamarin Components Store and found that someone has already created something called a signature pad. Now, the signature pad costs about $150, but if I were to write this myself and considered my time not being free, it would probably make more sense for me to just buy this component. So let's take a look at how we can utilize the Xamarin Components Store and add components to our projects to reduce the time it takes to create our applications. As briefly talked about before, you can go to the Component Store online and browse around a lot of different components. We have things like Azure Mobile Services, SAP Mobile Platform SDK, the signature pad that we talked about before, which is even changed to a free version now. So you'll also see here that it's supported for iOS and Android, and Azure Mobile Services is supported on all the 3 different platforms. Now, if we click on the signature pad here, for instance, we can see a lot of information about this. We can see how we use it, we get code examples, and we even get the price information and which platforms support the component. You can download the component directly from the Xamarin Components Store, which requires you to log into your Xamarin account. Another way to get the components is to head over to Visual Studio, right-click on your Components folder, edit Components, and now you'll get an overview of some very common components. But we can also click here, Open Component Store, which will load the components and show these components within Visual Studio itself. But we can click on our signature pad here, for instance, and say, add this to our application. And now we get a nice overview of the components that we have inside our application. And if we expand this here, we can see that it's currently downloading the signature pad component. And once that's done downloading, we'll see here that we have signature pad inside our application. And if we double-click this component here, we can see how we can interact with this component. We get information about how to get started with this. They give us information about how to do this in iOS or how to do it in Android. So think of this like NuGet. It's an easy way for us to add predefined components, even if they're free or costs money. So we can add this to the different platforms. We can add components to Android, for instance, and we can add the components to iOS. So this makes it very easy for us to use predefined components to make our applications even better. So hopefully now that it comes to the end of this tutorial, you'll have a good understanding of how cross-platform development works when it comes to the world of Xamarin. The idea here is that you have an understanding of creating an application that works on multiple platforms. You know how to create and use the portable class libraries. You know how to create and use the shared libraries, and you know how these differentiate between each other. And you also know where to find the Xamarin Components store and how to utilize that. Again, I'm Philip Ekberg, and it's been my pleasure being your tutor today. Feel free to ping me on Twitter or send me an email if you have any questions. Thank you so much for watching this video. I hope you learned a lot, and good luck with your cross-platform development.